Hello, welcome to lesson 3 of the topic reaction rates. In this lesson, we'll be looking at the effect of temperature on the rate of a chemical reaction. For this first part, we shall look at the theory behind the effect of temperature, and in a second part, we shall look at the graphical methods of determining the same. I would like us to consider two experimental setups. One setup will be at room temperature. The other setup is going to be heated by a Bunsen burner flame. We are using acid of same concentration in both setups, that is 20 cubic centimeters of 0.5 molar hydrochloric acid solution. We will then add the same mass of magnesium ribbon in both acid setups. I'd like to pose the question: what observation would you expect to make when equal mass of magnesium ribbon is added to the two setups shown below? Take time to think about it and post your response. Well, hoping that you've thought about it, let us consider what should be expected. As you can see, in the heated setup, when we add magnesium ribbon, there is rapid bubbling of the ribbon, and very quickly the ribbon diminishes. But in the first setup, the bubbling was slow and it took time for the magnesium ribbon to diminish. Why do we make this observation? Let us look at the theory behind this. Sticking to the concept of kinetic energy, we'll know that hydrochloric acid particles are in a constant state of motion. At room temperature, we will see that the rate of movement of these particles is the same. However, when we begin heating up one of the setups, then what happens is that the particles begin to move more rapidly. Heat is a form of energy, and it therefore adds energy to the particles. So with this kinetic energy, the particles begin to move faster and with more energy, so that when the magnesium ribbon is added in the heated setup, we can see that there is rapid collision of particles. The hydrochloric acid particles collide more frequently with the magnesium ribbon. For that reason, then the ribbon diminishes much faster because of more attack by the acid particles. In the second setup, or in the first setup where there was no heat, then you realize that the number of collisions are very few, and therefore the heated setup is going to show an increased rate of reaction, whereas the setup at room temperature is going to experience a lower rate of reaction. By collision theory, heat increases kinetic energy of reactant particles, so that they move faster and with more energy, creating more successful collisions per unit time. Considering what we have just looked at, what is the effect of decreasing the temperature on the rate of a chemical reaction? Explain your answer. Attempt this exercise and tune in to revision class to see if you made the right attempt. Before we close this lesson, I'd like us to have a sneak review of what to expect when we look at the graphical method. In this experiment, what we can look at is the rate at which the mass of the reaction vessel diminishes per unit time. We expect that we should have these two representation of curves on the grid, so that the steeper curve should indicate a high rate of loss in mass, whereas the gentler curve should show us a low rate of loss in mass. Tune in to the next class, where we shall seek to explore the graphical interpretation and manipulation of data as we consider the effect of temperature on the rate of a chemical reaction. Thank you for tuning in, and always hoping that this class was of great benefit to you. Have a good day.